All right, everybody. We'll just go ahead and get started, and then maybe more people will join in as we go. So this is going to be a bit more free-form. In the last two lectures, I don't have like a PowerPoint or really anything to go over. We're just going to kind of work in a Jupyter notebook together and hopefully try to get through some processing. I'll walk you guys through the stuff that is already in the standards processing notebook, and then we'll kind of work together to do the rest of it so we can calculate the concentrations and then do some plotting for the calibration curves. So let's all, as a group now, get a Jupyter environment started. And like I said in the chat, re-download the code because I made a couple changes to it, and then extract it again, and then navigate to that folder. And then you can open up this standards processing notebook, which is in the GC or the notebooks GCMS standards processing. So does anybody actually have that open already? Probably not. I'm imagining you guys have to download the stuff still. And actually, so at the end of this, I can walk you guys through a little bit how to use Git better, which is the software that GitHub is using to store this stuff, so that you don't have to download and extract zip files every time. You can actually just use the command line to pull down recent changes and stuff like that. So thumbs up if you're interested in doing that at the end of this lecture or today. Richard is. And Irvin, good. Yeah, so Git is basically the tool that pretty much everybody will be using for data analysis, or not data analysis, but for software sharing and development and stuff like that. And also, in addition to learning Python, it's also a very useful skill to learn so that you can share code and download code and do all kinds of stuff with it.
Sorry, where do we find the new code again?
It's just on the same website. So I'll put the link in the chat. 1 second. Navigate to the directory. There you go. And it's the same process as we did on Monday, where you just click on that green download button and then download a zip file. And I don't really want to start going through this until you guys all have it kind of open so you can follow along with me. And I realize it might be kind of hard to follow since most of you are just working on a laptop screen, but
oh, excuse me. Oh, where is it?
What's that?
Oh, where's the file? Yes.
The file?
Yeah, the standard.
It's in notebooks, GCMS, and then standards processing.
Was it in the Gaussian space?
No, you have to download it from GitHub.
Oh, okay. Oh, I see.
Yeah, the link I posted in the chat, just re-download the .zip folder and then extract it somewhere. And then you basically just need to navigate to that folder with your Conda environment activated so that you have access to all the libraries that we installed on Monday. And I'll be uploading the recording from Monday tonight. I just had to do some editing and my computer was being super slow about it. So that'll be uploaded on GachaSpace and posted in Slack this evening. And then I'll upload the recording from this one as well as soon as I can. So out of curiosity, go ahead.
In the folder, the analysis main folder, do we open the notebooks one or the GCMS data?
So yeah, the file that we're working with now is under notebooks and then GCMS. The GCMS data folder just has like the raw data and stuff, including the integration reports, which is what we're using to analyze. So I've been working on this for a little bit. And in the future, I'll be making more changes to this, this code so that you can actually read in the raw data as well, so that you can basically circumvent using OpenChrome at all, and you can just do everything in Python. But that's a little bit extra work, and I'm not expecting you guys to do that, obviously, but I just want to give you guys the tools so that you have a reference for this project in the future. It's just got a lot of good practices in Python and stuff like that. So yeah, root directory, notebooks, GCMS, and then standards processing.ipynb. And get a quick thumbs up check. Anybody is at this point yet? Good, got a couple people. If you're running into problems, don't struggle in silence. Just let me know, and I'll be happy to help get you there. Lily, by the way, were you able to get Anaconda working on your Windows 7? No. Okay, well, yeah, I guess you can just follow along with the recording, and then sometime later this week, you and I can meet and we can try to figure out a solution to get you Python working on your computer. Okay, so based on that last thumbs up, it seems like most people are kind of there. So I guess I'll start going through this. If you need some help, just interrupt me and let me know, and we can tackle it together. So we looked at this on Monday a little bit, and this is what's called a Jupyter Notebook, and it allows you to run Python code kind of in sequence. So this thing up top here, for instance, is a code cell. And then these other things that I've put in here, this is a markdown cell. So you can double click and you can see that it's basically just, you put in some formatting like this, and then it'll automatically know to like make a heading. So for instance, this hashtag and then a space, and then whatever title that says, that's a heading level 1. And then if you run this cell, you can see it just reads it like that. So Jupyter Notebooks are a super cool way to like explain a whole process of a data analysis progress. And so you can, yeah, intersperse your code cells with your markdown cells to kind of explain what you're doing. There's other options. There's raw. I never really use those, but code and markdown are the two main things that I use. So if you open this file in the repository, I think it should have none of the cells should be run yet. So there's no numbers in these brackets here. So we're going to go through and just run everything in the correct sequence. As I kind of mentioned on Monday, one of the downsides of Jupyter Notebooks is that you can run cells out of order. And if you haven't defined variables or functions correctly, like before you run a cell, you might run into errors. So you need to make sure that you run everything basically in order. So this one isn't actually doing anything. It's basically just loading some custom styling for tables and stuff like that. So you can ignore that for now. If you're curious, you can go look at this file, which is in the styles custom CSS file. I guess one thing that I guess we'll go down and talk about that in just a second. So all the stuff that's in here in this markdown section is basically just kind of a summary of the lab, so that when you're reading this, you can understand what's going on. But the real meat of this stuff starts happening down here. So the first thing that we need to do is basically tell Python where the data are that we want to start working with. And the current best practice for this is to use this pathlib library, which comes pre-installed with Python. So I'm going to run that cell, and I'm importing this object called path. And then you can see in this next cell here, I'm using this path object to tell the computer where the data file is that I want to load. So a quick show of thumbs up. Has anybody seen like the shorthand here for representing file structures or relative paths using like code like this? Anybody seen these like ... Anyone know what that means? Let's see. When I opened the GCMS folder in Jupyter, it only showed untitled notebooks. So let's, there shouldn't be anything untitled. Let me go quick double check on the repository here. So the one online has the standards processing.ipynb in it. So can you make sure that you've downloaded the most recent zip file from the GitHub page?
Yeah, I just downloaded it a couple minutes ago, and when I opened it, it gave me a blank notebook.
Oh, you probably open Jupyter Lab and then it just opens an automatic notebook. So you need to navigate into this to wherever you extracted the contents of your folder, and then it should be in the GCMS or the notebooks/GCMS file. Like it's an already created notebook. Actually, if you want, you can if you want, you can share your screen and I can kind of navigate you there if you'd like. This might be helpful for other people too. Does that sound okay?
Yeah.
Okay, so I'm going to stop sharing and then let me make sure that you are able to. You should be allowed to now. Okay. Yeah, can you maximize the your browser? So double click on GCMS, the folder over there. Oh, that's interesting. This might be the old version of the repository that you downloaded. So real quick, can you click on the top left of the file browser over there? There's that folder icon. Not that. Close this drop down. Click on, actually, let's see. So it's top left, like, so there's a slash and then ... / notebooks. So the file object next to that, click on the home. So where did you, it's probably in your downloads folder is where you extracted the file, right? So there's that. Okay, now go to GCMS data, or notebooks, sorry, misspoke. GCMS. Oh, that's interesting. Has anybody else encountered this problem where there's stuff that's not supposed to be in there, like these untitled notebooks? With a thumbs up. I don't know what caused that. So let's try re-downloading the zip file, Irvin, from GitHub. Or you can actually just go back to your downloads folder and you can find that .zip file. So, oh, it might be that we haven't extracted yet. Did you do this already? You're muted, just so you know.
Yeah, I did extract it already.
Okay. So yeah, let's yeah, so just go ahead and click, yeah, replace.
Replace, okay.
Yeah. And then that should be done. So let's go back to Jupyter Lab. And then you can just try refreshing the whole page, or yeah, you can just navigate there now if you want. Downloads. Let's make sure that this is, oh, so there's another subfolder here. So click on that Chem153 analysis main in there.
Okay.
And then notebooks.
Notebooks.
GCMS. There it is.
Okay.
So yeah, you can, after this, you can move this around to organize it a little bit better and it shouldn't change anything. But
okay.
Yeah, there you go. Great. So you can stop sharing now and I will start sharing.
Thank you so much.
Yep. Okay. So we're all here. Run this first cell just to import some of the styling. Hopefully all the markdown is already rendered for you guys. And then scroll down until you find this next cell, which we're importing the path library. And then, like I said, so this whole cell is basically just telling us where the data are that we're going to start loading in. Well, I made a typo there. Look at that gasoline file, but that doesn't matter because we're not even at this stage yet. We're basically just going to be working with the standards file for now. And so this syntax here tells the computer, go up 2 directories from where we are now. So that tells it go up to GCMS, up to notebooks, and then up to home, and then go down into the GCMS data folder, and then into the integration reports folder. And so if we go look and see what that looks like, so here's the integration reports. Let me get rid of this stuff here so we can see them. And then these next two lines are just telling, okay, add this string to the one that we just made to tell it where the standards report is. So that's this one. And then the gasoline one is here as well. These two things here. So I could have shortcutted and used the integration summary standards like we did using Excel, but I wanted to go through the process of how to load this data in Python and then clean it up to make those report data or the summary data, because you guys aren't given that for the gasoline file. And so you can use this same code basically to make the exact same file as the integration summary, but for the gasoline summary. So now let's run this. And that's just, there shouldn't be any errors or things like that. It's just telling you, okay, we're setting these variables here to these objects. And then next we're going to use pandas, which is a really common library for Python to work with things like it basically just makes spreadsheets, but in code. So we're going to load that. And then we're going to create this object called standard report. And I'm going to use pandas to read CSV. So this is a function that the pandas library has on it. And then I'm going to tell this read CSV function to look at the standards file, which we defined up here. So if we run this without this part down here, so if I comment this out and then run this cell, so we don't get any errors, but we don't actually see any output either. So to look at just the first 5 rows of this thing that loaded, you can use this function called head. And so you can see that I'm calling this function on the standard report variable that I just created up here. And then the syntax for calling a function is to use this dot and then type the name of the function. And if it's a function, you use these open and close parentheses, and that'll run that function. So if we do that, you can see that we get an output now that is the first 5 rows of this CSV file that we read. And we didn't give any kind of special arguments to this to tell it to skip anything. So this is just like the default thing that it reads in. And you can actually pass additional variables. So if you're in a Jupyter Lab environment, you can hit Shift-Tab when you're inside of a function like this, and it'll bring up some documentation that tells you how that function works and like some of the arguments you can pass to it. So you can see that it says this function will return the first n rows of a data frame, and the default is 5. So that's why it returns the first 5. But if we want to look at more, let's just pass in 15, for instance. You can see that it loads the first 15 rows and just shows them to us. And so this is the exact same structure as this integration report standards file. So if I double click on the CSV, you can see that it's basically the exact same thing, right? We have some of these empty rows between things. We have missing labels in these columns here. And for a human, this is really easily understandable. You can say, okay, I know that all of these apply to standard 1, bio 1, run 1, etc. But we basically want to tell Python to more explicitly label these things. And we also want to get rid of empty rows because they're not useful for code. So that's the next step that we're going to do. I'm going to return this back to its normal value there. And we're going to go through and clean the data. So that's what I basically just talked about. So we want to get rid of, first of all, these empty rows. So all of those things that are not a number. So we can see that certain rows are completely NaN, which stands for not a number. And we just want to get rid of those from our data frame. So Python has this built-in function again, luckily, which is called drop_na. And we call that again on the data frame that we created called standard report. This axis 0 tells it to drop rows and not columns. This how argument says if all of the values in that row are NaN, then we drop it, but not for any other ones. If we didn't pass this, it would also drop these rows here because there's not a number value in them. We would just want to drop the ones that are all blank. And then this in place argument says, don't make a copy of this, modify this actual data frame here. And this is something you don't really need to understand right now, but yeah, this is how we're going to do it. So let's run this. So we've done that. We didn't get any errors. Let's real quickly just take a look.
I actually got an error when I ran the code.
Okay, what did it run? What's the error say for you?
It says name error.
Okay. Name error, and then what's the text after that?
It said name error standard report is not defined.
You have to run this cell first. We need to define that variable. So this is where we're making the standard report object in Python.
Okay.
This is what I mean with Jupyter notebooks and needing to run them in the correct order. So yeah, standard report, you need to have this variable. And then right here, we can see where we're operating on that standard report object. And I'm actually just going to insert a new cell here just to take a look at that to see what it did. So standard report, and if I just, whoops, made a typo. If I just type it like that, it'll output quite a bit of it. So we can see now that there is no row between 3 and 5. So it dropped row 4 essentially, which is great. So I'm going to cut this now. And so the next thing we want to do, so after dropping these rows that all have blank numbers in them, we want to fill down these standard one, while one, run one, et cetera. We basically want to replace all of these not a number values below this with the value that's above it. And there's another built-in method called fill_NA. And just so you guys know, like I don't memorize all this stuff when I'm working with these things. Like some of them you learn, like especially the DataFrame head function, like you just know that one. But all these things, like you just basically look them up by going to like this pandas website here, and then you can go to the documentation and you can just browse like all of these function things. Like this is just the main page, but like you can learn how to do all these things just by Googling them online, which is what I do. So yeah, we're going to use this fill_NA method, and the method we're telling it is forward fill, ffill. And then again, we're doing it in place, telling it to just modify this existing data frame and not to make a new one. So let's run that. And then I'm going to add another cell below just so we can take a look at that again, standard report. So now you can see that it's copied those values down until we get to run 2, and then it dots, and these dots are just showing that it goes down to the bottom, but it looks like we don't have any not a number values anymore. And another thing you might notice is that these index values here, so like the row numbers, they when we deleted those rows that had the complete not a number values, it actually just deleted the whole thing, including the index. So this jumps from 3 to 5. But for the purposes of this experiment, it doesn't matter that much. But there are ways that you could re-index this and just basically say, you know, start again from 0 and go all the way to the bottom up to 108 or whatever. Okay. So now we have this data frame. Actually, why don't I actually just show that again, just so we know what we're doing. Standard report. So the way that this is formatted right now is not going to be super useful to us in order to do calculations. And this is just something that kind of comes with experience. But if you guys remember the structure of our summary standards, so why don't we open that up real quick? We can see that basically we've pivoted these things so that the retention times and areas are all the different columns, and then the different runs are just the row indices. So we want to do that also in Python so that we can more easily apply math to these columns the same way that we were doing it in Excel. So that's what we're going to do down here. We're going to actually make a brand new data frame that basically copies the data from this one here, but changes it or changes the shape of it. And so we're going to use this pivot function now to pivot the table. This is a function that's also available in Excel, but it's built into pandas as well. So we're making a new data frame object called standard summary. We're taking that data frame that's up here called standard report. We're calling this pivot method on it, and we're giving it some arguments. We're saying that the index we want to use is the standards column. We want to pivot on this column, which is these numbers here. So this is going to make a bunch of columns from each of these values. And then the values that we want to retain for those columns are the retention time and area. So what this does, I'm going to run this, is it gives us this new data frame where you can see that it's pivoted all those things over here. It's still not in a perfectly workable format yet, but we'll modify this in a second. We can see that we're getting to the place where we need, where we have all the standard runs here, and then the retention times for the various masses, and then the areas for the various masses. So what this did is it made something called a multi-index data frame. So this is like having multiple header rows in an Excel table, basically. And we want to flatten this so that we can, again, more easily do math with this. And I know that, you know, looking at this compared to Excel, it feels more complicated because it's not based on like the GUI environment of using a spreadsheet to like type all these things. But the power of this is that you can basically do all these things and make them into reusable functions so that whenever you have data like this, an integration report, you can just write a function that says, okay, do all of this stuff to that file and then spit out the report values of the actual concentration. So it basically eliminates all of the work as long as you put in the upfront work to do all this stuff to make sure it works. So the next step, we're gonna try to flatten these columns so that they have more reasonable names and values. So to do that, this is really complicated looking string of code. We could do this in multiple steps to make it a little bit simpler, but that's not really the point of this lecture today. I just wanted to kind of get us into a working state. So if you're curious about all these things, you can Google like all of these different kind of keywords here that I'm using in Python. But basically it's just taking these columns and then relabeling them and organizing them so that it is a flat thing. So I'm gonna run that. And it didn't have any output because I didn't tell it to print anything, but why don't we take a look at that again? So standard summary. So now you can see that running this one line function here changed all of our column values to just be replaced with the mass and retention time or the mass and the area. So now this is really similar to what we saw in this integration summary things here. It's not in the same order. So this goes retention time area for each mass. And this one just goes all the retention times and all of the areas. If you wanted, you could rearrange these. There's an easy way to do that using pandas, but for our purposes, it's fine to just leave them as is. Okay, so the next thing that I want to do, and this is kind of not a really necessary step, but I just figured I would do it. We notice that all of these areas are represented as something called floats. So they have decimal points after these numbers, but we know that it's a count, which means it should be just an integer, right? Like you can't get a fractional count of an ion hitting a detector. So I want to actually change all of these data types to just be integers. And so that's what I'm going to do next. So this little function here, it says for a variable in the standard summary.columns, if the name contains area in the name of it, then we're going to replace it with an integer type. So we're basically just changing the float value to integer. So if I run that, and then once again, we'll just inspect that data frame, standard summary. You can now see that all we've done is change these to integers. So we've gotten rid of the decimal points on these. And like I said, it's not super necessary in terms of the math that we're going to be doing, but when you have really large data sets and stuff like that, it can help you save computer memory by changing things into integers versus floats, just so that the computer knows it doesn't need to assign a whole bunch of memory to these numbers. Okay, so let's take a quick little break here. Is everybody following up to here? Has everybody been able to run these cells without getting any errors?
Yeah.
Okay, good. So if you run into an error at any point, just interrupt me and let me know. So the next thing we're going to move on to is doing this normalization, which we talked about both on last Wednesday and also on Monday. This cell here just kind of goes into the functions that we're using. So for the normalization factor for retention time, remember, we're taking the average value of the D8 toluene retention time minus whatever that actual D8 toluene retention time is for that run. And then for the areas, it's the average area divided by that instantaneous area. So we're going to do this in code as well. So this cell has a lot of things going on in it, but we can walk through them one at a time. So the first thing I'm going to do is I'm actually going to make yet another data frame. So I'm going to just make a copy of this standard summary data frame, which we made up here. So I'm just making a copy of this data frame where we've modified the column names and stuff like that. And then I'm going to add some things to this. So this syntax here. So I'm telling Python that I want to use this object here, which is a copy of the data frame. And I'm going to add a new column. And that's what this syntax is here. So you open up a square bracket, you type in the name of whatever new column you want to add. And I'm telling that it's going to be equal to the column that is the 100 retention time average of all of those numbers minus whatever the value of that column is at that point. So this is akin to in Excel typing in a formula saying equals average minus the cell next to it, right? So this is exactly what we did in Excel, but this is how you do it using pandas. And then it's the same thing here. So standard norm for the area normalization factor is just taking the mean of the areas and then dividing it by any given 100 area for that. And actually, let's see, I might be able to split the, well, okay, we'll just go through this next step here. So I've added these two new columns, and they're kind of just temporary columns because we don't really need them in our final results or anything like that. So I actually end up deleting them down here at the bottom. But for now, this is an easy way just to go through and calculate the normalized areas and times for all of our different columns. So here's a loop, another for loop. So I'm saying for every column that is in this standard norm table here, this data frame, if that column name has RT in it, then, okay, let me scroll up real quick again and show you why that works. So let's type standard summary here again. So you can see that our column names here all have either underscore RT or underscore area in them. And so scrolling back down here, what I'm saying here is if the name of that column, and I split the name on that underscore, and then take the last value from that split, if that's equal to RT, this is going to say, okay, this is a retention time column. Then I'm going to make a new column where I take the name of that column and I just append underscore norm to it, take the value of that column, and then add in the value from that RT norm factor column, which we made up here. So I know that this is going to be confusing and it's really hard to explain code in English when it's what it's doing, but we're basically just normalizing the retention times. So actually I might be able to open up the Excel file real quick and I can show you guys integration summary standards. Yeah, this is it. So back to this table here. So what we did is we basically, that RT norm factor is just this thing. So again, we're taking the average minus the given value, and the area is the average divided by the given value. And so all pandas is doing is basically saying, apply this function to every column that has a RT in it, and then apply the other function for the area normalization, for everyone that has area in it. So let's go back to Jupyter. And that's all of this whole loop here is doing, is normalizing our retention times and normalizing our areas. And then I'm taking an extra step here. So I'm dropping the column that we used to do the calculation, because I basically just want this final data frame to only be the standard normalized data. So I'm just getting rid of the ones that we used to do the calculation. And then down here at the end, I'm also just dropping the things that we used to do the calculation, the factors. So I'm gonna run this and then add another cell, and let's just look at that data frame real quick to see what it did. So you can see that we've now have all of our standards with their labels, as well as their normalized retention times and normalized areas. And again, they're not in the same order as the CSV file that we got from the Excel, but we can still do a math on these from here. So again, everybody good running up to this point, no errors. Any questions about what we've been doing? Cool. Okay, I'm gonna cut this again. So the next step, which we were talking about on Monday, is right, we need to calculate the concentrations of each of these analytes within these standards in order to actually construct our calibration curves. And so this is kind of what I was working on today and yesterday. And I haven't got it working completely yet. And so I figured we could kind of go through this together as a team and try to figure this stuff out. Just because I'm still working on this and it's not done yet, it doesn't have a bunch of annotations like the stuff up here. So it's mostly just code right now with no labels and stuff like that. So we can kind of run through the thought process of how we'd be going about doing this. Yeah, go ahead, Richard. Sorry, gonna wait for him to type. Yeah, you can so you can export data as CSV. So why don't we do that? That's actually a great idea. So this standard norm data frame, again, let's just type it again to see what it looks like. So we want to, if we wanted to export this as a CSV, we could say to CSV. So that's a function that Pandas has. And then in here, if you type the name of the file that you want to do, so let's go back to our notebooks and GCMS here. So if I just want to say standard norm.csv, if I run that cell, you can see it just made this here. And if I open that, it's got all the data in there. It does look like these things did not get rounded to integers, which is maybe something we can think about fixing in this. But anyways, the data, yeah, really easy to export. To CSV is the function. So yeah, you can take the data and analyze it in Pandas, and then you can export it as CSV and then plot it using Excel if you want to do that. Yeah, so actually, while we're here, why don't we fix that problem with the areas not being integers, right? So that's happening here. So we're saying the standard norm area normalization column. So it's applying this normalization factor. So what we actually want to do is we want to round this to an integer. So I think we can try this. We can do int and then do that. So just wrapping this whole thing in this integer function, and it should try to just round it to the nearest integer. So if we ran this right now, it might run into a problem because this this data frame already exists right now. So what I'm going to do, if you encounter this kind of problem where you like keep adding columns to a data frame that already exists, you can go up to here to kernel, restart kernel and run up to selected cell, or you can, there's a couple options here, but I'm going to restart and run up to this cell. And this should, after a couple seconds, get down here. Okay, we had a problem. So cannot convert the series to integer. Okay, that's great. So that doesn't work. So the next thing we can do instead of that, so let's take that same column. So standard norm f call actually, well, okay. So yeah, see, this is live coding. So this is making it into a floating point number, and we want to actually change that to integer. So we can look back up to what we did up here. I'm going to cut this cell again. So okay, so we casted that as type int. So why don't we do that? So, oh, scrolling too far down. So let's take this, and I'm going to copy this value here, line, and just say as type int. Is that what I did up here? Let me just double check. Yeah, as type int. Let's see if that works now. And again, I might have to restart the kernel and run up to that cell. Okay, no errors. So let's just see what that looks like now. Standard norm. Yeah, so it looks like it did integers. And to check that, we can actually do .info. Nope, didn't make them integers. It's still 60. Oh, we might need to do in place true. That might be the thing that runs. So now I'm going to restart the kernel and run all the way up to here. Nope, doesn't like in place for that. So, okay, why don't we do something else? Instead of as type, we can do .apply lambda x, oops, round, let's see, int x. Let's try that. who knows if this will work. Again, I don't claim to be a Python expert, so I'm just kind of doing this as we go here. Did I do that right?
I never had any issues with like getting the integers to work. I think the first time we ran the integer code, like it just straight up like showed up as an integer, at least like those columns for the area.
Oh, interesting. So yeah, for mine, it's this part here that's, yeah, it's doing the problem because it's multiplying by this area normalization factor, which is a float. So it's multiplying an integer by a float, and so it gives you back a float number. So might have to round, that's what I'm saying. Like for this part here, we want to round it back. So does apply have an in place thing? No. So yeah, I mean, we don't have to do this right now. It doesn't really matter. But this is something to play around with. So let's just restart the kernel, run up to here, get back to where we were. That's fine. So float 64s are fine. The only problem you run into is when you have really large data sets, then float 64s take up more memory than integers, like I was saying before. Okay, so let's move on to this calculating concentration stuff. And as I already mentioned, this is in progress, and so we'll talk about it together. This starts to go into a little bit of what's called object-oriented programming. So instead of just writing functions to do things, I'm actually defining something called a class here. And so basically what this is doing is saying, I want to make a new object type called an analyte. And it has these properties. It's got a name, it's got a molecular weight, and a density. And I'm picking these things because I know that in order to do these calculation concentrations, I need each of these things, right? Like we need at least the molecular weight and the density, and then the name will allow us to differentiate between these things more easily. So that's all that this code is doing, is setting up this object called an analyte. You don't need to worry about these methods here, the repr and the string. This init method is just how you tell a class in Python to build itself. And so I'm going to run this real quick. There's no output from this. And let's just show an example of this. So let's make a new analyte, and we're just going to call it random equals analyte. And then in order to do this, I need to pass in these variables here. So if I just run this as is, it's going to give us an error and say, oh, we're missing things. It needs a name, it needs a molecular weight, and it needs a density. So let's give it a name. We'll just call it random. We'll give it a random molecular weight, just say 100.1 for fun. And then a density, we can also just say 0.765, whatever, it's all random. So if I run that, now we've made this new object that's called random. And so I have access to this now. So if I just type random and run that cell, you can see we get this thing back that says, okay, this is an analyte. It's got this name random, it's got this molecular weight and this density. To access those different things, you use, again, the dot syntax here. So if I wanted to do random.name, that tells me it's random. And actually, let's make this a little bit simpler. So random will be the variable name. We're going to call this xylene, just a random chemical. And these are not the right molecular weights or anything like that. But anyway, so random.name is xylene. Random.molecular weight is 100.1. And random.density is 0.765. So now we have this object called random that we can use to do calculations by accessing these properties on it using this dot syntax here. So that's my thought process for doing this. And then I also defined a function down here which allows us to calculate a concentration for some given molecule and an initial volume and then a total volume. So this is basically doing that function that we did in Excel that, you know, calculates the concentration of the stocks. And so you basically pass in, as this molecule thing here, you pass in one of these analyte objects, and that'll do the calculations for you. So you can see here within this function, we're saying the molecular weight we're going to be using is whatever the molecular weight of that molecule that we passed in is, and the density likewise is the density of that molecule that we passed in. And then we calculate the concentration using this function here, which is just a copy of the calculation we did in Excel. And then I'm just rounding it to some arbitrary number of decimal places just for fun. not essential. And then the final step is just to return the value of this concentration as the output of this function. So let's do that real quick. So let's say calculate conc. So I'm using the name of this function I defined here. Let's pass in random as our molecule. Let's say that the initial volume, and these volumes, by the way, are in microliters, which I'll add as comments so that you know what it's supposed to be. Let's say we're taking 20 microliters of it, and we're diluting it to a final volume of 1,000 milliliters or something like that. So this now will output this as the concentration. So it says it took these data from this random object and calculated the final concentration in moles per liter using a initial concentration or initial volume of 20 microliters of this diluted to 1,000. So this basically allows us to calculate all of the concentrations that we need later in the experiment just by reusing this function. So we don't have to do it for each individual case. Does that kind of make sense to everybody? I know this is a lot of Python stuff that maybe you guys haven't seen the syntax and stuff like this yet, but these things will come to you as you learn the basics. Anybody have any questions before we kind of move on? Okay. So I'm just going to delete these things because we're just playing around with them there. So the next step that I wanted to do is to create kind of a new data frame that has the information that we need to calculate our concentrations of our stocks. So I'm going to scroll back up real quick to where we have this table, which tells us how we prepared our standard solutions, remember? So all of these volumes in microliters, then a total volume, which is 2,500 microliters for each of these things. So basically what I want to do is I want to make those analyte objects for MTBE, toluene, and benzene, and then use the numbers from this table to calculate what their final concentrations are, both in the stock solution and then finally in the actual solution that we injected into the GCMS. So that's kind of what I'm in the process of doing down here. So the first thing that I do, and I realize again, this is a really complicated one-liner function, but all this is basically doing is making a list of each of the analytes that I want to make. So I'm saying, all right, so this analytes list is going to create a new object of the analyte, like we just defined up here, for a name, a molecular weight, and a density in this other list where I've then defined all those things that we need. So we have MTBE with its molecular weight and its density, benzene, its molecular weight, its density, toluene, etc. So this makes this object. So if I run that, and then let's just look at what analytes is, you can see it's just a list of those analyte objects. So we can now use this to basically make our own custom data frame from these. So that's what I'm doing here. So I first just define another list of the columns that I know that I want in this data frame. So it's going to be the compound, which will be like the name, and then a volume and another volume and a volume, all for the different standards. And then the data that I want, so I want to first, for the first row, I want to grab analytes 0, which says grab the first item from this list. So actually, let's do that. So analytes 0, that's this first thing from that list. So this is MTBE. So I'm saying, okay, for MTBE, here's the volume that I want for the standard 1. Here's the volume for standard 2, standard 3, etc. Then the next row, I want toluene, actually. And so I skip to the last object in the data frame. So if we look at analytes 1, that's benzene, and then analytes 2 is toluene. And that's because of the order that I defined them up here. So you could change these around, but it doesn't matter. We can access parts of the list using these things like this. So next is toluene with those volumes, and then benzene with those volumes. And then I'm saying, let's make a new data frame called stock. And I'm going to use the stock data. So this whole list here, and then I want the columns to be the columns that I named up here. So if we run this now, you can see that we've got this simple data frame that has essentially a reproduction of the table that we made up here. It says my internet connection is unstable. Am I cutting in and out for you guys at all? Okay. Yeah, my internet had an issue for a second there. Hopefully everything's okay now. So are you guys following? So we've made a data frame that basically is this table minus the chlorohexadecane. That's this thing right here. Cool.
I'm having a hard time getting the one-line analyte code.
This line here.
Yeah.
Okay. What's it telling you?
Like I haven't like received any errors, but like I don't like see anything like happening.
Oh yeah, well the cell as it is doesn't output anything. It just sets this variable analytes to this whole thing here. And so if you make a new cell by clicking the plus sign, and then you just type analytes, then it'll output this stuff. Does that work for you?
Okay. And yes, but I have another question. How is like this one-line code different from like the one you did like right on top, like above?
Right on top.
Yeah, yeah, that one.
This here.
Mm-hmm.
So okay, so this is defining a data structure called an analyte. And this isn't making anything yet. This is just telling Python that I want to make something called an analyte that has these properties here. And then to actually make one of those, like we did, so to make one, you have to basically, you tell it to make something. So if we just want to type analyte and then pass in name, the molecular weight, and then a density, these are just arbitrary numbers. So that makes an object now. It makes one of these things called an analyte. But until we do that, so that's what this code is doing here. It's making 3 different analytes using this list here. And like I said, it's complicated. I did this in one line using something called list comprehension. And so what we could do, why don't we go through this one at a time, and we'll show you how I would do this. So I'm going to make an empty list called analytes2. So this is how you make an empty list in Python. You just say, okay, some variable equals empty brackets. So I'm going to run that. No output. So if I wanted to, I want to add something to this now. So I'm going to say analytes2 dot append. This is the function to add something to a list. I want to add a new analyte object called MTBE with a molecular weight of 88.150 and a density of 0.7404. So if I run that, no output again, but we've added that thing now. So if I run another cell and look at analytes2 again, you can see we now have this object in there called MTBE. Does that make sense?
Yeah.
So then I could go through, like, basically what this line here is doing is just doing this same thing 3 times for these different conditions to make a new analyte. And this is some intermediate level kind of Python stuff called, like I said, object-oriented programming, and using this list comprehension thing. So I'm not expecting you guys to just immediately understand how to do this. It takes a lot of time. But yeah, so we're making a list called analytes that has 3 different analyte objects in it that have different properties. And then we can use those to do some more math. So I'm going to cut these out now. So we're at this point here. We have a data frame that has our compound names here, and then the volumes for each of those things. And so something kind of interesting here is that even though, so this is just saying this is representing just MTBE as a string. But if we look at what that thing is, so I'm going to grab that first object here. So this is saying, remember, we made it, this data frame is called stock. And then I'm going to say, okay, in the stock compound column, grab the first object. So if I run that, you can see that it actually gives us this analyte object, which we made up in here. So we said, okay, remember the stock data, that first column is an analyte object. So even though it's represented in this column just as the name of it, it actually is an object. So if I wanted to say I want to look at the molecular weight of that thing, you can see I can just call that molecular weight property and I can see it. So now we can kind of start to do math with this stuff. We can make new columns that'll calculate the final concentrations of these things by applying some math. And this is kind of where I was right before class started. I'm trying to figure out the way to do this correctly, and I've been running into some problems with it. And again, it's because I'm not a super Python expert, but we can go from here together and try to figure this out. So is everybody able to run up to this point and get this data frame here that has our compounds and the volumes and stuff? Thumbs up. Cool. Has anybody not been able to do this besides Lily, who has Windows 7? If you have not been able to do this, do some other symbol from Slack. I don't know what the emojis are. Okay. Okay.
For me, sorry, I just have a lot of issues. I got, for the stock one, I got a key error.
Okay. Running.
It's just like a long message saying there's a key error.
Yes. Was it running this cell here that says stock columns and stuff? Or which?
Yeah, I think so.
Okay. So yeah, select this cell again, and then go up to kernel, restart kernel, and run up to selected cell and see if that fixes it for you.
Okay.
All good?
Yeah.
And then you should just see this table as the output of that cell. Okay, so the next thing we want to do, right, is we want to make some new columns, or at least calculate some things that give us those concentrations. Let me open back up the Excel sheet that we had. So remember, we made this table here, which has our different concentrations of each of our analytes for the different standards. And this one here is pivoted from the one that we're working with in pandas. There's no real reason for that other than, I don't know, it's just the way that I decided to make it using Python. But let's go through and try to figure out how to do this together. So back here, I'm going to delete this again. So okay, so here's kind of where I was at. So this line of code is saying, okay, I want to make a new column again in this stock data frame called standard 1 stock concentration, and I want it to be equal to the value of the stock data frame at the compound column. Apply this function here. This is a lambda function. Again, this is something that you guys will not have heard of in Python. It's a thing to look up. Lambda functions are kind of useful, but I'm saying, so for a given compound value, I want to calculate the concentration. So this is calling back to that function that I made right up here, calculate concentration. I want to pass in X. So I'm just using a variable name X, but I can say, let's say compound instead. Compound. So running this, in theory, should make a new column with this label as the column title, and it should calculate the concentration based on the value of this compound and the value of the volume that's in standard 1 column. And then 2500 here is the total volume, because remember, we're diluting everything to a final volume of 2.5 mils. So if I run this, I also get an error. And I'm not really sure why. So it's a value error at the bottom here. So the way that you read these errors is usually you go down to the bottom. This is called a stack trace. So this is going to be the main thing that went wrong. So, and then you can start kind of working up from here to figure out exactly what happened. So wrong number of items passed 3, placement implies 1. I don't really know what that means. That's something down inside of pandas, basically, it looks like. So you can see this line here is telling you which file encountered that problem. So this is in the pandas library that we installed, in the core module, internal, blah, 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 all that stuff. Doesn't really matter. So we can scroll up until we find something that is relevant to our actual thing here. And we never actually get there. It's all pandas errors. And so we get this key error, standard 1 stock concentration. And so I think it's just saying that it doesn't find this column. And so it's not able to apply this function to it. And I'm not really sure why. So let's think about how we can do this. So we want to basically make new columns where we're using these values to calculate those columns. So I'm just going to comment this out. I'm going to run it again just to clear it for now. Oh, by the way, to automatically comment something, you can do control and then /. So that character there, if you type control in that, it automatically puts a hashtag in front of the line, which is how Python recognizes comments, which means don't run this code. That's just a nice hotkey there. So if we look at stock again, let's figure out if we can find a way to calculate a value. So I'm going to try just doing compound 0. Whoops, made a typo. So this should grab this MTBE object, which remember has all the properties of this analyte class up here. Let's calculate concentration using this as our first argument. So remember, the first argument is the molecule, and then I want to pass in the value of standard 1 volume. Oops, standard 1 volume. Jesus. Live coding is hard, guys. And I want to grab again that first value. So yeah, the syntax here is if you first do a brackets and the name of a column, it'll return the whole column. And then if you include another brackets with a number in it, it'll give you the index or the value of whatever that index is of that thing. So this is like standard 1 volume row 1, basically. Python starts at 0 index. So that's this number here, 50. And then a final concentration of 2500. So just want to see. So that gives us this number of 0.168. Let's go double check. That's what we should expect. Yeah. So that calculation is working correctly, right? But we want to make sure that we can apply it now to every column of that data frame or every row of that data frame. So let's see. Let's try writing a function for I in stock stock standard 1 stock conc equals calculate conc of stock compound I. So I'm grabbing this I value. This is let's add another thing just to show you guys real quick. So for I in stock print I. So this grabs, this only grabs the columns. So yeah, I'm not sure. This might not work. For I, let's try, okay, for I in, how about this? Range 0 to 3, do that. So let me show you what this does for I in range 0, 3, print I. So this just prints 0, 1, and 2, which are the indices that we actually want to use. So for I in range 0, 3, we want to make this new column where we want to calculate the stock on the compound there. Okay, so this might work. And then the volume of the analyte we need is stock standard 1 volume. And then the final volume for all of them is 2500, right? So this should work. Let's try that. No errors, good. So let's now take another look at stock. Okay. These numbers don't quite make sense, right? So that's not the right number for standard 1 stock of MTBE, right? So what's happening there? Oh, I forgot to do this. I need to access that actual number from it. So instead of multiplying all the values, I want to multiply just this 50. Let's try that. Oh, Okay, that didn't work. So anyways, anybody have some ideas of how we could do this? Again, like I said, I'm not a Python super expert. So we basically want to go through each of these columns and use the values of the rows to calculate the concentrations. And maybe somebody knows more about this than I do. If not, then I can kind of work on this on my own, or we can try to figure this out together by reading some of the documentation. Or if you guys are all up to it, I can, like I said, I can spend some time on this on my own, make sure this works, and then we can have another meeting. I know we're not supposed to have any more meetings for GCMS, but if you guys want to, we can try to find a time to schedule it. Does that sound okay to everybody?
Yeah.
Yeah.
Okay. So yeah, for the people that are here, has this been useful, like, or is this kind of just way over the top Python stuff?
It definitely makes way more sense than Mathematica, and that's how like I first started.
Okay. Cool. Yeah. So I really wanted to do this Python stuff because I think it's a very useful and cool way to do stuff, and especially if you learn how to do this well, then your careers in grad school or whatever job you get are going to be so much easier. So yeah. So why don't we stop here for now, and I will spend some more time figuring this thing out. Like I'm almost there. I feel like with this thing, I'll figure this thing out, and then we're also going to go into the plotting part, so to actually generate the calibration curves with the trend lines and stuff like that. So I'll send out a poll with a meeting time, some meeting time options, and we'll try to schedule a time for either later this week or next week, if that's okay with all you guys. So does that sound good?
Yes.
Cool. All right, so yeah, your homework. Oh, I haven't told you guys, by the way. So the due date for this report, like I said at the very beginning, I want to make sure you guys have plenty of time to do this because I realize it's a lot of work to process the data, create the figures, and write it all up. So I think according to the syllabus, it should technically be due like next Wednesday. Is that right? Or even this Friday, but I want to give you guys at least until next Friday. So does that sound like an okay time for everybody? So basically a week and a half from today for the final report, or would you guys like longer?
Could it be due on Sunday night?
This Sunday?
No, like the following Sunday.
Sunday night. Yeah, that works for me. So Sunday, let me look at my calendar here. So that would be what? Not this coming Sunday, but yeah, Sunday the 9th for the final date at like 10 p.m. Does that sound okay to everybody?
Yeah.
Yeah, that sounds good.
Okay, so we'll do that for now, tentatively, and when we have our next meeting to talk about Python stuff, I'll try to gauge your progress and make sure that we don't need more time. Please, on your end, put in some work this weekend and stuff like that to try to get to a place, do some work to get to the end point for this, just so that I know that we're there. I realize sometimes when I set deadlines, every student just kind of waits until the day of to do it. This report is going to take more than the day of, I think, to get it all done. And I realize it's a lot of work, but please try to do some work beforehand so we can actually have a fair assessment of whether or not we need to turn it in then. I'm happy to extend it if we need to. There's no reason not to. But yeah, for now, shoot for Sunday the 9th by 10 p.m. We'll adjust as we need to next week. Sound good?
Yep. Thank you so much.
Okay. Yeah, I'm gonna work on this code and I'll push new changes to the GitHub, and then you guys can download it from there and we'll work together and set up a new meeting time. All right. Have a good night, guys.
Thank you.
Bye.
Bye.